First of all, today we are going to start here one important topic in the engineering mathematics 1 semester 1 सेम 1 के लिए ये टॉपिक important है. This topic it is an maxima and minima by Lagrange method. Okay, regular method maxima and minima you can see the previous lectures. Okay, so this topic will be asked in your final exam Mumbai University for 6 to 8 marks. Okay, so without wasting the time we are starting here the first example. मुझे मालूम होना चाहिए how to find the values of x y by using Lagrange method. Okay, so this method is very simple. Solution: first we have to know what is the given function, so just denote here f of x y. Suppose let xy equals to, what is the function it is given, x square plus y square, and consider another one function that is supposed to be phi of xy and which is suppose here second function it is given, or we can say the condition, and this will be writing in this format, that is x plus y, and these 2 we can take in the left side, then it is minus 2. Okay, so this function will denote as a phi of xy. You can say suppose it is equals to 0. Once this get in this side, we can consider equals to 0. Now we have to write this important step, that is what we have to write here, the Lagrangian function. So this step is very important. Consider the Lagrangian function. What is the Lagrangian functions? We have to consider that for that L of xy which is equals to f of xy plus Lagrangian multiplier, that is consider suppose lambda of phi of xy. Okay, so ये step important है. We have to consider this equation. Just complete this equation. Suppose this is an 1. Now I am writing this function, that is L of xy. Just try to complete this equation. So f of xy means this f of xy, and what is the value? Simply x square plus y square, and plus this lambda as it is, and phi of xy. Okay, so phi of xy means this function, and what is the value? This is nothing but x plus y minus 2. Okay, this is our second equation. This part is very important to write here the equations. Okay, and then after similar way we have to just write here the derivatives. So first order derivative we can write. So suppose here the function L is, I am again writing, that is x square plus y square plus lambda into x plus y minus 2. It is our actually equation number 2. Okay, we are differentiating this with respect to x and y. What happened, we can say, so partially differentiating above equation with respect to x and y, then we get what we get, derivative of fl with respect to x. So we can write the derivative, that is x square, it is a 2x plus derivative of y square, obviously with respect to y it is 0, plus derivative of this next, so lambda it is constant, derivative of x it is 1, plus derivative of y, it is 0, and obviously minus derivative of 2, again it is 0. Rewrite this, it is a 2x plus lambda. Okay, and second part, that is the derivative of L with respect to y, and this will be getting simply 2y plus lambda. Okay, so equation number 3 and equation number 4. Again we can differentiate that derivative of L with respect to lambda also, and that time the x square derivative, y square derivative will be 0, and lambda into x plus y minus 2, that derivative will be as a constant. So lambda derivative, it is 1 with respect to lambda, and rest of the part, this derivative is nothing but x plus y minus 2 as a constant. So this will be equation number 5. Okay, so in this way you can write the two important terms, that is what, sorry, three important terms, equation 3, 4 and 5. Okay, let us consider here all the derivatives supposed to be equals to 0. Then what happen? Okay, if I am considering equation 3, that is the derivative of L with respect to x equals to 0, then what is the value of derivative of L with respect to x? It is simply 2x plus lambda equals to 0. If I am solving this for x, then it is nothing but x is equal to minus lambda divided by 2. And similarly, if I am considering the second term, that is 2y plus lambda equals to 0, then what happens for y equals to minus lambda by 2. We have two values, that is x equals to minus lambda by 2 and y equals to minus lambda by 2. Okay, it means that x equals to 1. Okay, whatever the value of x, which is equals to 1. Now put these values, putting these values in x plus y minus 2 equals to 0. Okay, x plus x plus y equals to 0. Then what happened? We get the value of x, it is minus lambda by 2 value of y is again minus lambda by 2 minus 2 as it is equals to 0. Then if I am solving this, then minus 2 lambda by 2 minus 2 equals to 0. Then we can write 2 get cancelled, then minus lambda minus 2 equals to 0. Then simply we can say lambda equals to minus 2. Okay, so this can be written as lambda plus 2 equals to 0, and in this way lambda equals to minus 2. Okay, so once we get the value of this lambda, then we can define the value of x and y also. Okay, so let us see what happened. We have lambda equals to minus 2, and we know the relation of x, which is equals to minus lambda by 2. It implies that if lambda equals to minus 2, then minus 2 divided by 2, and which is nothing but minus minus plus, sorry, so it is 1. Okay, and similarly y equals to again minus lambda by 2. It means that minus 2 by minus minus plus and it is nothing but again 1. So in this way we can find the value of x and value of y. Okay, these are the required value. X and y, so we can calculate. So we first know that the function f of xy is what? That is nothing but x square plus y square. Now if I am putting here the 1 square plus again 1 square, then it is 1 plus 1, and which is nothing but 2. Okay, so 2 is a maximum or maxima for the values of xy which is equals to 1 1, and this will be the final answer. Okay, so such kind of the problems may be asked in your example. Very simple way we can find the value for x and y. What is the procedure? Once again I am repeating. Whatever here are the given questions, first you have to find out two functions are there in subject to the conditions. Okay, so this is our main function, that is f of xy. Here we are considering. Okay, and with condition is there. Okay, this is our condition. From these two equations just write single function called as a Lagrange function. Okay, that one. And after that just find out the partial derivatives with respect to x, y and lambda. Okay, you will get three equations. What are the three equations? This one first, second and this third. Okay, these three equations. Now after that the similar way, first consider which is equals to 0 and calculate the relation between x and lambda. Okay, similarly y and lambda. Now these values of x and y put in the second equation. Second equation means what? Equation of phi. ओके, इसमें पुट करने के बाद x का वैल्यू पुट करेंगे, y का वैल्यू पुट करेंगे, तो आपको लैम्बडा का वैल्यू पता चलेगा. Once you know the value of lambda, then rest of the part is very simple. Now once you get the lambda value, this is suppose 2, then in relation between x and lambda put the value of lambda, you will get the value of x and y. Okay, and after finding these values of x and y, now this this is supposed to be your solution. Okay, x and y. Now this value we can put in the x square plus y square, whatever the value we can consider, this will be a maximum. Okay, because of their positive values. Obviously for that particular x and y, more than 2 value will not get. Okay, so we can consider this will be a maximum value. If you get the negative value or something else answer or 2 values, then we can consider maximum minima, but maxima because of the maximum value of that particular function. Okay, I hope ये समझ में आया होगा. If you like this video, just hit the like button. अपने दोस्तों के पास साथ भी शेयर करना, और अगर आप YouTube चैनल को फर्स्ट आए हो तो इसको सब्सक्राइब करना. ओके, सो थैंक यू फॉर वॉचिंग. सी यू.